Hey everybody, it's Azim here, and we're looking at this fun-looking thing. We're going to be going over connective tissue histology. What we're looking at right now is a section of embryonic tissue. We're looking at the beginnings of mesenchyme, beginnings of connective tissue. That was at 40x total. I'm going to go to 100x total. We're going to get a bit closer. We want to look at the connective tissue, so where I'm pointing the arrow right now, and wherever it's lighter is where the connective tissue is. There we go. So this is called mesenchyme. Mesenchyme is the embryonic tissue that leads to all the other connective tissues, whether it's a fluid connective tissue proper, or a solid supportive connecting tissue like bone. You can see that these cells, they're all kind of spread out, and they have these little branches. Those branches are collagen fibers, and so this is the framework for the extracellular matrix. Again, this is mesenchyme. We're going to start out by looking at all the connective tissue proper. We'll look at the other connective tissues in a different video. So first, let's start with the loose connective tissues. There are 3 loose connective tissues. And when we say loose, we're talking about what we see in the extracellular matrix. So we're looking right now at a tissue that has very large round cells. This is 40x total, 100x total, 400x total. These are adipocytes. We are looking at adipose tissue. You can see wherever it gets darker, like where I'm pointing my arrow and down here. These are the nuclei, as well as all the organelles. What's stored in these large white areas, that's where adipose is stored. So adipose fills up the cell and pushes the rest of the contents of the cell off to the side. The main purpose of an adipocyte is to store adipose, and we need that for cushion, for energy storage, fat storage. So they kind of look like little rings. Like this is the plasma membrane is a ring, and then the part where the nucleus and organelles are, that's like where the diamond or whatever kind of jewel is. They kind of look like simple squamous epithelium, like the ones in the lung, but you would see many more nuclei in the lung because epithelium demonstrates cellularity. There's a lot of packed cells together. And these cells are packed, but there are fewer of them relatively. There is collagen. You'll have to believe me that there is collagen in between these cells in the extracellular matrix. So there is collagen in between these cells. We are switching to another loose connective tissue proper. This tissue, we're at 400, let me go back to 100. This tissue is called areolar connective tissue. And areolar connective tissue is like your do-everything connective tissue. It's a little bit stretchy and flexible. It's a little bit supportive, a little bit cushiony, not too rigid, but not too soft. It does everything well, kind of well. It does everything kind of well. All those nuclei you see, well, most of those nuclei you see are called fibrocytes, nuclei of fibrocytes. But all the squiggly things you see and lines you see, those are fibers. We said that there was collagen in between, excuse me, in between the adipocytes here in areolar connective tissue. We've got 3 fiber types. We've got collagen, which is long and straight. The wavy one that you see, that is elastic fiber, and so elastic fiber, as you might imagine, is stretchy. And then we're looking for dark branched ones. Dark branched ones are reticular fibers. I think this is the best we're going to get over here. Dark branched ones are reticular fibers. The background ones, I should say, like the faded background ones, those are collagen. Dark branched are reticular. Wavy are elastic fibers. This is areolar. It's found deep to the skin, like just deep to the epidermis. Sorry, not deep to the skin, deep to the epidermis. It's found deep to pretty much every other type of membrane, mucous membrane, synovial, and serous membranes. Our third type of loose connective tissue is much more rigid. It's called reticular tissue. That's class. Don't pay attention to that. There we go. We're actually looking at a lymph organ here, but I'm going to look deeper in that lymph organ. This is at 40x total, 100x total, 400x total. And we can see how there are lots of dark branched lines in between the lighter stained nuclei. The nuclei, those cells, I forgot to mention this with areolar, those cells are called fibrocytes, or maybe I did mention it. Well, these cells are also called fibrocytes. The dark branch fibers, those are reticular fibers. So areolar tissue did have reticular fibers, but this only has reticular fibers, and they're very dark, very branched, very prominent. They're found in organs that are more rigid, like the liver, the kidney, spleen, lymph organs. Provides support. Those were the three loose connective tissues, and they're called loose again because you saw some white space in between them. Already with this one, you can see that there's pretty much no white space in between the fibers, in the extracellular matrix. We're at 40x total, 100x total, 400x total. So what we can see here, there are nuclei, and those are nuclei fibrocytes. Let me change the focus a little bit. There we go. But you can see that these fibers are all going in one direction. Right now it's horizontal. These fibers are very tightly packed close together. The white space that you see, that's just because of shearing that happened during the cutting process of creating this tissue sample. But this is a dense, regular connective tissue. Dense, regular. It's white and fibrous, so it's also called white fibrous tissue. But dense, regular, it's very, very strong, especially in this one direction that you see. This, in this case, horizontal. Where do you find dense, regular? You find this in tendons, which connect muscle to bone, ligaments, which connect bone to bone, and sheaths, like what covers muscles, or sorry, fascia, which are like sheaths that cover muscle and organs. So this is very strong, but only in that direction of pull. If you have something going in the up-down direction, a force that's going up in the up-down direction in this case, that would cause tearing. So it's very strong left to right in this view, not very strong in the other direction. So it cannot withstand shearing forces, which is why it's possible to tear a tendon or a ligament. But it would be because of a force in that opposite orthogonal perpendicular direction. Dense, regular. So that's dense, regular when you have a bunch of fibers going the same direction. What if you have a bunch of fibers going different directions? If I can get this slide to stay. Here we are. We're actually in the skin right now. You have simple stratified squamous at the top, keratinized stratified squamous. Where the arrow is right now, that's actually areolar. So this is areolar. But starting here, where the arrow is, and going all the way down, and that's adipose down here, so this is adipose. What's sandwiched in between the areolar and adipose, this is dense irregular. And what you see predominantly are collagen fibers that are going many different directions. This is 100x, excuse me. Let's go to 400x total, and you can see how the collagen is cut in many different directions. Some are in cross sections, some are longitudinal, and a lot are obliquely cut. Dense irregular is also strong, but not as strong as dense regular, but this provides multi-directional strength. Dense irregular is a great cushion for multi-directional forces. Our last connective tissue proper is similar to dense regular in that the fibers all go the same direction, but it's not primarily collagen. We're at 100x right now. We are in the aorta. The aorta is the largest blood vessel of the body. I'm going to go to 400x. It's the largest blood vessel of the body, and so it has to withstand all the pressure of blood coming out of the heart. To withstand all that pressure, it needs to be stretchy and elastic. So what we need here is elastic fiber. And you can see all those elastic fibers in a single direction to help withstand that pressure coming from the heart. This is elastic connective tissue found in the aorta and other places that need to stretch out. Again, all the fibers are going in pretty much the same direction, but they're much more squiggly, much more coiled than what we see for dense regular. So those are our connective tissue propers plus connective tissues proper plus mesenchyme, our embryonic connective tissue. In other videos, we'll go over the other connective tissue types.